Well, the whole point of an air filter, we want to know what it can do, what it's removing from our air, and what it, if we stress that system, what we're putting into the air, what it can pull out. Shortly after I joined the company and learned about the Purity Air, the first Purity Air system, I gathered together all of the test results that we had, because we hadn't really, we could say we had room for improvement in our publication of our test data. When we were moving toward releasing the new Purity, or what we call the Purity Multi-effect Air Filtration System, we wanted to actually start that launch with the test data available for all the users. One of the things that we noticed is that despite the size difference, as you can readily see comparing the old unit versus the new unit has such a large size, and consequently we would expect it to move a lot more air but it actually runs at a comparable noise level. So we have at 30 centimeters away from the unit, our tests on the original unit showed a 74.5 decibel rating, and at about the same distance we have on a high setting, we have a 68.2 on the new unit. That would be on the first unit was 74.5 was on the turbo, the highest level, and on the high was 65. So 68.2 versus 65, we compare high levels. So we have, despite the larger size, a very similar noise rating. It shouldn't be any louder than the older unit, but you get the added benefit of more air moved at the same time. And you also get more energy efficiency. We have, in terms of energy usage, the current unit, so it's rated for 90 watts, and our test data actually showed a little bit lower than that. So the HEPA systems actually, so for those who have, if you get a copy of the white paper, I've included both in the original system, the white paper for the original system, and I've carried this over to the white paper for the multi-effect system, an explanation of what HEPA is. And HEPA is high efficiency particulate air, or it's also used absorbing or arrestance. Basically, it's high efficiency particulate filtration. And it's a standard that was developed in the first half of the 20th century. It was in the 1940s by the US military. It was actually in the development of the atomic bomb. It was the Manhattan Project that they developed this scheme, this standard for air filtration. They had to have a high clean room situation to do the research. And this HEPA standard has advanced from there. And so there are various levels of HEPA that are classified. And we see, for example, in the European Union, they've broken it out into multiple different levels. We have, our test data would fall into the H13 rating for HEPA. And our test data on this new filter show greater than 99.99 or 99.99% or of most of the particulates that we've got. We have very small particulate filtration down to the 0.1 to 0.3 microns in 25 minutes, greater than 99.99% filtration. The stage of the filter is a combination of different metals and different polymer filter systems, with the inclusion of activated carbon and zeolite, which were also in the original Purity filtration filters. In our study here, doing multiple tests of this, we retained, after saturating a filter and then running the test again, really a worst case stress test for the filter. After 3 times of saturation, we still achieved greater than 93% filtration. And this is not exactly a percent reduction, because they were saturating the system and then charging it again and filtering it all out. And so we still see this great efficiency repeated after worst case scenario testing. If we go to the PM 0.1 to 0.3 micron, so this would be bacteria. We filter out any bacteria. The bacteria their lower limit in size is 0.3 microns. And then we also, this category would also include larger viruses. Certain viruses in the news today would measure about 0.12 to, 0.12 to 0.16 microns in diameter. And so this PM 0.1 to 0.3 micron in 25 minutes, this multi-effect filtration system removed greater than 25 minutes, greater than 99.99% of the PM 0.1 to 0.3. And then we did a test for less than this, a PM less than 0.1. So this would include carbon dust, certain smokes, and then smaller viruses. And we ran this test for 180 minutes. Overall, after 180 minutes, we achieved a 99.74% reduction in this PM less than 0.1. So this is ridiculously small particles. And we see in 30 minutes, we got 96.86% reduction. That additional 99% versus 99.9%, we're looking at, it may not be noticeable to your eyes, you may not smell it, but those particles that are present, if you've removed 99%, there may still be a little bit, and you may get by with a 99% reduction, but there may still be a little bit, and if you are really sensitive populations may notice this. Your average person may not, but you're getting that added assurance that you've removed an additional level of reduction. Now, when we're talking 99.9% or 0.99%, when we look at it in terms of 99 is one out of, if there's 100 to begin with, there's only one left. Well, if you're talking in air, in 1 cubic meter of air, we have, I want to make sure I have the right number here. We have 1 cubic centimeter of air would contain about 2.7 times 10 to the 19th power molecules of air. So that's a really huge number. And if we're removing 99 out of every 100 of those, we see that that's quite a small number, but there's still, if we look at, then it would be 2.7 times 10 to the 17th would be left. That may sound like a lot, but compared to the original number, it's very small compared to where we started. But with every 9 we add, we're dropping that power of 10 number of molecules by 1. And so therefore, we see that we're drastically dropping those numbers of particles present. We can summarize that. I know I was giving a little longer explanations before, but we can say, because we only have bacterial test data, we can say that we can make specific claims for these specific organisms that we've tested. But the other biological contaminants of interest, that would be fungi, protozoa, and organisms, and then viruses, we would also expect reliable filtration based on the size of the particulate materials that we do have data for. Fungi and protozoa would fall in the larger size, the PM 2.5, for example. The PM greater than 0.3 would apply to bacteria, for which we do have results. But then also viruses would fall in the smaller levels, like PM 0.1 to 0.3 and less than 0.1. So we have greater than 99.99% in each of these cases, the PM 2.5, PM 0.1 to 0.3, and then we have up to 99.74% reduction on the less than 0.1, which would be our smaller viruses. Now, as I mentioned before, certain viruses that are really famous right now would fall in the range of 0.12 to 0.16 microns in diameter. So they would fall in that middle size range of 0.1 to 0.3 particulate material, for which we have greater than 99.99% filtration. So hair and dust would be considered large particles when it comes to air filtration, and they would be very readily removed by this filtration system. As far as odors, depending on what is causing the odor, it could be a particulate. As far as it could be a physical particle of something that may be larger, or it could be the organic compounds themselves that would fall very small, maybe less than 1.1 microns. The great thing about this filter we have with the multi-stage approach, which includes the activated carbon and zeolite. The activated carbon and zeolite filtration stages contain micropores, which will absorb these contaminants, especially if they're volatile organic compounds or other, we could say gaseous compounds like an odor, that would absorb them from the air and trap the substances in their micropores. And that's how this particular filter would remove those. Some air systems will use they'll use a UV system is very common, or they'll use other systems to oxidize materials, which will kill bacteria, viruses, fungi. But if they don't remove shall we say the leftovers, they don't remove the dead organisms from the air, then you're not resolving all of the air concerns. And so this, in being a particulate filtration system, this system will remove the hazard, because if it's trapped in a filter, the bacteria or virus or fungi don't affect anybody. They're trapped in the filter. And so it doesn't matter whether or not it's killed, because it's not circulating in the air. This system does it removes to a degree that I think the average user would find more than sufficient. Unless you plan to have a clean room in your home, like working on microcircuitry, but except for those highly specialized situations, you can't go wrong with this system. It will more than meet what the average user would require.